Perfect. So, hey, everyone, welcome again to Cloud Collective. We are a group of folks here at Egen that like to share our understanding of a lot of cool stuff, cool technologies, and some unique approaches out in the world using this forum. And that's how we have been running it for the last 2.5 years. Yeah, even before COVID. After COVID, of course, when everything is remote, it's mostly through webinar, and we love this format as well. So, I'm Praveen Salitra, Head of Technology here at Egen. I've been here for almost 9 years, almost 9 years. Yeah, next week I'm going to be finishing 9 years. So, been here as a software engineer, but then now, of course, leading the entire organization on the engineering side. So, have been working with a lot of awesome folks, architects, engineering managers, and group where we do some crazy stuff here. Who is Egen or what is Egen? We are a cloud and data engineering expert company who are trusted by some of our top clients, mostly in the Chicagoland, but now we have been growing as well and working with the customers outside Chicago as well. We have been located in Naperville, a southwest suburb of Chicago. What we do, so for the last 6 years or so, where we have focused more on working with enterprises to modernize their legacy infrastructure or technologies or platform, working with some of the most popular unicorns out of Chicago as well, helping them scale in the last few years or so. And then here and there, we have worked with some fresh entrepreneurs as well, launching their digital platforms, especially if they have some cool idea and stuff like that. So, pretty good work with respect to not just the domain perspective, but then also on the technical side as well. If you think again from the domain perspective, we started 6 years ago working with one of the largest OEM in the world on the industrial IoT side, mostly dealing with real-time sensor data, CRM data coming from the dealerships, and then of course dealing with some other contextual data as well, whether it's weather, geography, anything like that. And then of course dealt with a lot of unique things that comes with that vertical, especially in the data and data science. In the last 2 years, started working with healthcare as well. Some of a couple of customers that we have at this point, where we are dealing with different sort of technical problems at that point. More dealing with structured and then unstructured or file-based data as well. Genomics data formats, mostly dealing with that as well. And then of course, healthcare being very I would say compliance-oriented domain, obfuscation, de-identification, data sharing, all those kind of things are primary compared to, let's say, industrial IoT, right? 2.5 years ago, we have jumped into retail as well, and now we have a lot more customers on retail than anything else combined. So in retail, typical use cases there as well, whether we are helping them to go through or maybe implement real-time order management system for some of the largest grocery retailers in the country and the world. And then, of course, all the things with respect to the POS integrations, maybe mobile app platforms, internal apps, and things like that. So the whole idea is whatever the domain be, our technology or engineering philosophies are still similar or same, whether it's all about event-driven architectures, whether using Kafka, which we love very much, have been using for almost now 6 years, or using some of the services from the cloud providers as well on the similar domain. Modern data pipelines using either our own orchestration engine or using another set of orchestration for these pipelines from cloud services. And then, of course, microservices, serverless services, or I would say more cloud managed services, automation end to end, and then, of course, finding out where things are going wrong using observability stack as well. So, pretty much a lot of good stuff in terms of both domain as well as technical side, and then that shows up in our technology stack as well. Whether we talk about JavaScript stack or TypeScript stack end to end, mobile apps, web apps, backend APIs as well to a very large extent. And then, of course, traditional enterprise stack, if you can call it. But then a lot of new engagement, a lot of new projects we have been doing in the last few years are around cloud and data stack that we have been doing. So if you are interested, we have always positions open, at least in the engineering side, if not all of them. So yep, go and check it out on egen.solutions/careers. You will be somehow connected to me ultimately in the recruiting pipeline, recruiting process as well. So, yep, that's about Egen. Coming back to the talk of the day today, and today we have Sri Harsha, who is our software engineer here at Egen. Have been here for almost a year and a half now. Been dealing with a lot of things in industrial IoT, of course, with machine data as well as some other sort of data coming from other systems as well, not just machines. We have been using Elasticsearch in different configurations across our customer base as a primary data store, as a typical text search engine and analytics engine as well. So we have had a lot of experience with that. So Shri today is going to be talking about, hey, if you want to start on Elasticsearch, and if you are coming from a SQL background, right? Maybe for many years you have done relational databases or you have written SQL. Now, let's say if you want to jump into Elasticsearch, how do you go from the key concepts in SQL and how do you map them into Elasticsearch if those things are available there or not, and things like that. So over to you, Shri.
Thank you so much, Praveen, for that introduction. And I think you can see my screen, right? Cool. So it's covered. All right. So hi, welcome all. My name is Sri Harsha, as Praveen just mentioned. So this session is part of a meetup series, and we're going to talk about Elasticsearch and how we can use that Elasticsearch in our system. And yeah, so without delay, let's start. So before talking about Elasticsearch, let's talk about SQL and the relational database. I'm expecting like most of you would be aware of this. So it's basically traditionally it's been used as most of the data stores in the entire applications. So it's like the combination of tables and rows, and each entities, the expectation is that the entities are related to each other. And all of those properties, like ACID properties, are like transaction oriented, and we usually normalize them so that we can reduce the redundancy. And the rest of the process are the same, that we use SQL for querying the relational databases. SQL is just a language to use the relational database to access relational database system. And SQL or relational database provides several complex logics like stored procedures or functions. And this is also used, of course, in legacy systems, much more larger scale systems where they have large chunk of data to be stored and where their entities are related to each other. We have several examples of SQL, and these are different SQL relational database systems that we have right now, which are very popular. There are many more, but at least these are most popular ones, like MySQL, Postgres, MS SQL, or called Microsoft SQL, or Oracle. This is just to give you like, okay, what SQL is about, and then mostly all of us are aware of it. So then let's come to the concept of today's session, right? The whole Elasticsearch. Elasticsearch is actually part of Elastic Stack, which was developed by Elastic Company. But this Elasticsearch is combination of Elastic Stack is a combination of Elasticsearch, Kibana, Logstash, Suites, and much more software services or software tools that were provided by the company Elastic. Elasticsearch is initially developed on top of Apache Lucene, which is a open source text search engine library that is available out there. And Elasticsearch is actually built on top of it. So it's a NoSQL database. So it's also a document data store, as we know. And this is mainly popular and so advantage to use this because you don't have to worry about horizontally scaling this, because its inbuilt mechanism is actually was designed with horizontal scaling in mind. So you don't have to think about, okay, how do I, if my index or if my data store entity gets larger, how do I handle that, right? All those things are designed in beforehand itself, and so that you don't have to worry about all those things like horizontal scale. And Elasticsearch is all of the APIs or all of the access that you can do in Elasticsearch is via REST API. So that's one more powerful thing. And there are several use cases of Elasticsearch. So we have listed down few here. One, Elasticsearch can be used for log aggregations. Then it can also be used for text search, document store, observability and APM metrics, and for security and information event management. I will just give like brief about what are these different use cases are, especially text search. You have seen the video, the introduction that we gave for the session. So imagine we have something where you want to implement a text search in your system, right? So you have a list of users and you want to see, okay, give me those users who start with, let's say, an example named John. When those kind of things occur, Elasticsearch is so popular in this region. So you don't have to worry about thinking about different use cases, lowercase, uppercase, or word positions and stuff. Text search is inbuilt, developed in Elasticsearch. And then we have observability and APM metrics. So imagine, like, let's say if you want to aggregate, or you want to monitor your application performance, right? So those advantages also you get with Elasticsearch. Then, yeah, so as just to recap, so Elasticsearch is the primary data store of where all the data would be stored. This is often called as the heart of Elasticsearch, heart of Elastic Stack. So because basically Elasticsearch is the main thing. And for ingesting the data from various systems, you can use different systems. These are just a couple here. We have several others, but these are like most prominently used: Logstash and Beats. And then for visualizing your data, you can use Kibana. So Kibana is something where you can visualize data, plus you can do much more. Like you can create graphs, you can create metrics in Kibana. Next, so we have talked about Elasticsearch. Now, how can we like run Elasticstack, right? So the first, like, Elastic Cloud is actually the cloud-based offering provided by the Elastic company itself, the one who is currently behind the Elastic Stack. So they provide this as a service. And then if you're really comfortable with Kubernetes, you can actually use ECK operator to run it on your Kubernetes as a self-hosted. The third option is, like, if you really are so comfortable with your own self-hosting and then have a cloud provider, GCP, Azure, or AWS, you can actually use a virtual machine cluster setup, and then you can run Elasticsearch on your own in there. There is one more note here. So we have another Elasticsearch service. So recently there's been some, I think you might have followed actually. So there's been some differences with respect to licensing and how Elasticsearch should be open or how it should be licensed. So Amazon, who initially came up with a service called AWS Elasticsearch service, now made it called AWS OpenSearch, which happened recently. And we're going to have a separate meetup on that because that's going to be a complete whole discussion. At Egen, we mostly prefer running it at Elastic Cloud, which is like a cloud offering provided by the Elastic company only, or else running it on Kubernetes, because it's so easy and you don't have to worry about running it on your own. And then one of the main problems that we saw, like with our experience, like when we are running on self-hosted on our own cloud provider, is like it's so hard to maintain when things go wrong. But whereas if it's a managed service, and especially from Elastic company itself, there are a lot more advantages and makes our life easy when we are handling Elasticsearch. Now, let's see. We talked about Elasticsearch now. We talked about how to run it. Let's see, like, where does it fit? We have a product API, or in other words, like a backend API, and we have a front end, right? And then that front end makes CRUD calls, right, using HTTP, just like many companies do that, or most of the applications do that. And this use case of Elasticsearch is to just store it as a primary data store, to use it as a primary data store, right? So we have our entire Elasticsearch cluster And our product API uses the CRUD operations to store the data inside the Elasticsearch cluster. So this is one of the use case or where we can use Elasticsearch into our system. Now, you can see these terms here, like ingest, data, master, 01, 02, right? Or one. So you don't get too overwhelmed by it. Those are like different kinds of roles that a particular node can play inside Elasticsearch. But we have much more in-depth information or much more detailed session planned next week. So for now, just keep in mind that this Elasticsearch cluster block that you're looking at the screen is just where the data gets stored, right? So this is one of the use case. Although there is no problem using it. It's just like a NoSQL or document store that you're storing your data store. It's not quietly popular. The other major popular use case of how companies use Elasticsearch is same setup, right? So you have a backend or a product API, and then you have a front end or UI. Front end makes a call to the product API, and then you store the data into your relational database, right? So all of the data and all of your relations between entities are ensured. And then you make a CRUD API to access the data inside your database. And then you have a separate Elasticsearch cluster, right? So what you would do is you set up an indexing or a syncing mechanism between the actual database that you have in relational database inside Elastic, and you send the data to Elasticsearch cluster with search in perspective. So that for any search operations, the request could be sent to Elasticsearch cluster instead of going to the relational database. I'll give you a small example here. So let's say that you have a requirement, right, where you want to see about, okay, how can I, like say you want to list down products, right? So like Apple, Mango, all just the product names, right? If you want to do it via the traditional way, with NoSQL here, you have to go and see, okay, get all the product information from the SQL, right? But you just need the names here. You don't want to see what is the entire object of that particular product, right? You just want to see the names. It's just a simple example, but when you have Elasticsearch, right? So what happens is like you design your Elasticsearch with search in mind. So you don't want to mimic the exact way that you're storing in your traditional database inside Elasticsearch, because that is just you're just copying the data from one data store to other, right? Instead, what you want to do is like you want to take out the fields that you think that, okay, or you foresee in your business requirement, okay, these are the fields or these are the entities that I think that I can perform the search on, right? And you design your schema, you design your Elastic cluster in such a way so that it's more optimized for search operations, because the data security and everything is already there. How the actual data gets stored is already there in primary data store, right? It's just for the search operations you actually use Elasticsearch. So this is just a simple example to give you an overview over there. Now, let's talk about the differences between few things, like how we see about internal concepts of one relational database and what about Elasticsearch, right? This is like high level analogy between the two, so that to give you an idea about what things are and what are the terms that they use. So database in a relational database is where we have tables, right? So the similar one in Elasticsearch is called index, okay? And then when we have a table in Elasticsearch is called type, okay? And each row in the table is called a document, and each column in that table is called fields, right? Each column in that row is called field. And the way you design this, like you create a schema, that's nothing but is a little bit similar to mapping. Now, this is not completely true. This is just like a high level comparison, just to give you an idea, because it's not completely exactly the same, right? One of the major differences is in database in SQL world, in a single database, you can have so many tables. That's how we create our database in SQL. But in Elasticsearch, the initial versions of Elasticsearch had this feature that a particular database in Elasticsearch, okay, let's say a particular index could have actually had multiple types in the initial versions, but in the latest versions, they made it just one type in the per index. So basically one index will have just one type, all right? And then let's come to the columns. In SQL, each column is just a single field, right? It's either varchar, integer, float, number, or date, right? It's just a single field. It could be student ID, student name, whatever. But in Elasticsearch, it could be a single field, or it could be nested as well, right? So a simple example is this that we have. I'll go with each and individual field here to explain. So so this is just one like kind of document, okay? The one that we are looking at, the source, is the actual JSON document that we have, okay? All those fields above source, or even with the like all those fields here, are the metadata of that document, okay? So if you look at the document, you could have a single field like course, and you can have an object like an array like student, right? This you can't achieve it in in SQL, right? Because in SQL, it should have a single field. If I want to design the same thing, or if I have a similar requirement in SQL, I would probably have two different tables and use an ID in between, like connect the entities, right? Or implement a relation between these two entities, right? But here it's just like, okay, we have a course or we have a student object, which is an array. And then we have another professor object, which is not an array, but it's an object itself, right? So if you look at the different kinds of fields that we have, this is not just a single field. We can be nested fields as well. This is like a very basic example. Sometimes the nested fields can grow, like you can have a list, right? That could also be happen. So there's no problem with that. Now coming to the other fields here, so I'll just give an overview of that. If you look at the first field here, like underscore index, this is actually the index name, my index 0, like that index name. And then the type is what I was mentioning earlier. Initial versions gave you the feasibility of having multiple types per index. But in the latest versions, at least from 6, I think they started deprecating from 6, and then with the 7, they completely removed that feature. So current version is around at around like 7.14, or 8 is going to come up very soon. So with that approach, like there's only one type per index, okay? And then the ID of the document, which is 2, fair enough. And then the version of the document. We'll go into much deeper later, but just get a little bit awareness of it. So version is nothing but the number of times the document has been updated, okay? And then the sequence number and primary term are two things that are used by Elasticsearch for concurrency control. We'll go into much deeper later. And then we have source, which is nothing but the actual document. So this is just like how a typical document and the metadata related to the document looks like when you perform a search. The actual search that I did is right above in that comment, get my index doc2, right? Whereas the first line before the slash is just the index name, and then the type, and then the ID. These are the different ways that we actually can interact with SQL, right? So like DDL, data definition language, data manipulation language, there are different ways, right? You can create table, you need to perform certain commands to do that, right? It's specifically mentioned there. With Elasticsearch, everything is REST API. Again, it was being like modified or updated pretty good in the recent versions. Earlier versions, they used to have a low-level client as well, but after that, they just made it like REST API. So even though Even the Java libraries that you use in the latest versions, it's all REST APIs. And the one easiest thing here is, right? So if you look at here, I don't need to have a CLI, right? So for SQL, let's say if I'm trying to show you a demo on Postgres, right? I have to download Postgres CLI in my machine, and I have to connect to the system, and then use that CLI to run some commands, right? It's same with MySQL as well. With SQL, is very simple. So all I have to do is like use either curl or any other HTTP clients to just call or use the methods of what Elasticsearch provides. This is one of the methods that it just shows the cluster information and what is the information, like what's the version of it and other things, but it's just that the basic information. The takeaway from here is you need to have a CLI or a tool to use or access your data in SQL, but whereas in Elasticsearch, all you need to do is have like curl. You can even use Postman if you're aware of it. So it will make like so easy to access the data. So after this, like the next concept is like the coming slides. The way we'll go forward is like to take a concept and then how we can differentiate between our like relational database and Elasticsearch. The first comes, okay, right from scratch, what do we do, right? We create a schema, right? So it should be defined initially. All we know, so we should create a schema, like create table syntax, we should define it initially. And also once you make the table, right? Once you define a table, and if you need some change to it, it is so hard in SQL, right? So that you have to make sure that the data is not calling it and kind of block the reads and then block the writes as well, and then do those changes. Maybe there will be some downtime to it, right? If you want to change the type of the data, for example. So this is just a simple syntax, right? So you use a create table persons, and then you'll use person ID, full name, varchar, right? So it's simple. The Elasticsearch, although you don't have to specify a schema, which is actually called as mappings in Elasticsearch initially, right? You don't have to specify that. By default, Elasticsearch, although tries to map 1,000 fields. Now you can ask, like, what is the difference between map versus storing the data, right? We'll come to that later. But by default, let's say how many documents that you store, if you don't specify the mapping. By default, Elasticsearch maps like 1,000 fields. And that limitation came just recently because they tried to fix a major problem called mapping explosion, where people don't, when people forget to create a mapping and they start ingesting or they start indexing, nested objects, and the mapping keep on increasing, and it causes so much of issue with memory consumption for the cluster, and that would eventually blow up the entire cluster. And that's basically called as mapping explosion. So, but now we can just understand that, okay, we have to specify a schema in relational database, but in Elasticsearch, you don't need to. Now, yeah, I want to show this example here and then talk through each point. So this is how I create an index. Okay, I'm creating an index with a mappings inside it. So I'm creating a person index, or because as I was saying that it's like there is no types here. There's no multiple types here. There's one type _dog. So I'll just say I'm creating a person index with a mappings. And the problem that we saw in here, right? Like harder to do any changes once the table schema is created, that can be solved in Elasticsearch with multi-fields approach. Okay, so for example, here, if you see in this mappings, the same, like I think both of the fields are the same, right? We have person ID here, we have person ID here. The full name, you can actually store it as text, and you can also store it as keyword. Okay, and I'll tell you what the difference are between those two. But before that, if you look at here, I create an index and I'm specifying a mapping. Inside mapping, I'm saying that what are the fields or the properties that I want the mapping to be done for. The fields are nothing but columns, right? It's similar to that. I'm saying the person ID is a type of integer, all good. And for full name, I'm saying it's a type of text. And then I'm saying that, okay, I'm creating one more fields inside it called a keyword, and it's a type of keyword. Simple difference is between, let's say my name is Sri Harsha, right? When I store Sri Harsha as a text, okay, and when I search for a word called Sri, I would get the result back, because text type fields actually go through text analysis by Elasticsearch, which is one of the awesome features that Elasticsearch provides, where it takes down the stop words and stores those words separately internally, okay? So even though I search for only Sri, it gives me the results because Sri is part of the word called Sri Harsha. But let's say if I want to have certain fields where I want to search for specifically, if I give the whole word called Sri Harsha, right? In that case, those type of fields go as keyword fields. That's what we did here. So a field like my name, Sri Harsha, can be actually stored as text. And if I want to store it as a keyword, it can be stored internally as full name.keyword is equal to Sri Harsha, right? And Elasticsearch will handle that keyword mechanism internally. So you don't have to worry about it. So depending on your use case, you can query on full name, or you can query on full name.keyword. Both of the things will be handled automatically by Elasticsearch. And one major important thing is, like, even though Elasticsearch is lenient that, okay, you don't have to provide, and even though they fixed this issue, like they kept a hard limit of 1,000 fields in the recent versions, it's always advisable to create mappings ahead of time, at least the base level mappings, so that you would avoid mapping explosion, which I think because they fixed it is very less chance, but still there is. As you talked about schemas here, let's talk about the next thing. So once you created a schema, right? Or once you created a table, what's the next step that you want to look for? You want to look for primary keys, composite keys, the foreign keys, or the uniqueness of each individual row, right? This primary key concept is actually not supported in Elasticsearch, okay? But each individual document in Elasticsearch is actually identified with a unique underscore ID field, okay? And then this unique underscore ID field would be able to, is unique implicitly, okay? Either you provide it, or even though if you don't provide underscore ID, Elasticsearch generates a unique ID for the document, and that will be staying unique for that particular document. You can even create an empty document with an ID, and ES would actually accept it. It doesn't complain, which is different to what SQL does, right? In SQL, let's say you create you say, let's say, person table, and you say person ID is the primary key, and then person name, other regular fields. You can create an empty row without providing a person ID, right? In the document, the source document should contain it. In Elasticsearch, it doesn't need to. So if you see an example here, the first one, you just gave an ID, but you don't have any document there. Okay, I just told, okay, tweet is the index, underscore doc is the type, and no object ID is an ID, right? But I gave an empty object, right? So there's no source, but this is just an empty, basically just an empty row, There is one workaround which could be done if you want to mimic mandatory fields, okay? Which is to set dynamic is equal to strict, so that you don't actually allow new documents to be indexed. I'll take you back 1 second here. I think I forgot to mention what does dynamic stand for? So dynamic is where you're telling to Elasticsearch, okay, person is the index, right? And currently, when I'm creating this person index, I'm telling I'm only interested, like person ID is integer and full name as the two fields, right? And I'm telling dynamic is equal to false, okay? And okay, let's say I'm indexing the documents. All the documents that I'm indexing right now, let's say they only have two fields, person ID, full name. Good. I got a new document that I'm indexing and it has a phone number, okay, which could happen, right? You can't foresee what are the new fields that can be added to a document, right? And you get a phone number into the document. Elasticsearch doesn't complain saying that, okay, you only gave me person ID, full name, and I'm going to reject your document, right? That is when you set dynamic is equal to false. So you're saying, okay, only map person ID and full name. But when you get a new document with person ID, full name, and phone number, don't reject it, store it, but only map inside the document, only map person ID and full name. The main difference between mapping and storing is mapping is where you can perform Elasticsearch operations on those fields. Like I can query those fields, right? I can query, okay, where person ID is equal to 1. But if a particular field is not mapped, then I can't query on it because Elasticsearch just stored the whole raw document as it is internally, but it didn't set up, it didn't has that key to search the document for, So for you to perform operations on the fields, you have to have those particular fields mapped. That's the difference between mapping and storing, okay? And this setting, especially dynamic is equal to false. So what it does is like, so if, as I was saying, so person ID and full name, it indexes all the documents with person ID and full name, all good. But if I get a new field, it doesn't reject it, but will just store it, but it doesn't map that new field. Whereas the other setting that I showed here called dynamic is equal to strict is, let's say you have person ID and full name as you want those two fields to be mandatory fields for all the documents, right? If you want those two fields to be mandatory fields, but if you try to send a document without that particular field, like full name, right? Elasticsearch will reject it because you specified that that particular field should be part of the mapping, right? But you said dynamic is equal to strict, so strict doesn't even let the document to be indexed. That's the basic difference between dynamic strict and dynamic false. Of course, the default is dynamic true, whereas, as I said, Elasticsearch by default, as long as it reaches the limit of 1,000, it will try to map all those fields. Next, like we covered, like creation of the schema and then create, the primary keys concept. Let's talk about relational database, or sorry, the joins here. So this is one of the simple example here. We don't have the user table shown here, but imagine there's a user table and there's a tweet table, right? There are two tables. And so if you look at here, there's a tweet ID, tweet text. So I'm trying to get the tweet information from the table tweet, and I'm joining the account A, where there's actually a relation between these two, right? And they are joined by user ID. But then I'm actually looking for a username called John, right? So this is how, like, let's say you have a tweet table and user table, and they both have the tweet ID as a link in between, as a relation, as a foreign key. But then I ask you a question like, okay, can you please give me the tweets that was tweeted by John, right? You can't do it unless you perform a join, because you don't have the username information of the user inside the tweet table, right? So this is a basic join that we do. So, it can be either, like, this simple requirement can be either be done by a join query or an inner query too, right? It doesn't, because it's a simple join operation here. Now let's say we have a similar requirement in Elasticsearch. Okay, so we have two indexes, and one of that is, right? So we have two indexes here. One is user and one is tweet. Before all, I think one important thing to note is, like, joins are not supported in Elasticsearch. Okay, in a single query, you can't connect multiple tables. Like in SQL, in a single query that you run, You can connect multiple tables using joins. That's the main advantages of join, right? Or multiple entities, and then retrieve the data, either one of those or like from all of those, the common data or whatever. In Elasticsearch, the major concept is like, it is designed as if like each entity or each index is separate on its own, right? So you can basically write a single query. So we were like, okay, where these two entities connect using user ID, right? In this example, give me the documents. No, it can be done. The solution, although, if you want to do that, is something like this. So the first query, what I'm doing, like I'm doing a search, right? And I'm saying that, okay, give me where username is equal to John, right? And the result is what you're seeing on the right side, sorry, where it gave you the information, right? Similar to what I was showing earlier, it gave you the ID, it gave the source, and you have a user ID here. So what we need to have in between is kind of like a middle layer, like a program, like a Java program or Python or whatever. And we will store that particular user ID, and you'll do one more query on the tweet index where, okay, give me all those tweets where user ID is equal to 1, and you'll get the results. Now, this is not the optimal solution, right? This is not what you want to do. Because if this is the case, you're just again falling back on the more awesome features of Elasticsearch, right? You are basically again trying to set up a relation between two entities and trying to take from one and trying to retrieve from the other. The solution to this, or the much more optimized solution, is you have to design your indices with search in perspective. You don't want to just store them as data. You want to keep it as search in perspective. And one important thing is you have to denormalize as much as you can, right? You want to denormalize. That's one of the major thing of NoSQL, right? You want to denormalize as much as you can. And your document should contain all that information that you think that you will perform searches on, right? So what the optimal solution for this would be, the same tweet index, instead of containing the user ID, like if you're seeing on the right side, line number 23, 24, instead of containing the user ID, just these three fields, it will also contain user details as well. And this is not like to copy or keep everything into one index. The main reason why we do this design is because we know, okay, a UI or an application can search for a tweet using either user ID or username, right? That can happen. That's normal, right? That's why we want to make sure that all that denormalization is done, and the particular index will contain those documents, so that when they search for a particular username, search tweets by username, the results are automatically given to them. So that is one important thing with respect to joins and how you should handle it in Elasticsearch compared to SQL. Now let's come to transactions. In SQL, we might be aware of this, like the asset properties, right? The different asset properties we have: the durability, the isolation, the consistency and atomicity of the particular row, right? Or transactions or the date that is supported for transaction level, right? So you start, let's say you're trying to insert several rows inside SQL, right? And one of the insert queries is messed up. The syntax issue or a data type issue or something. So what would happen when you try to complete the transaction? The entire operation that performs on the disk, which gets stored, the data gets stored internally, right? That would be dependent on the completion of the entire transaction, right? It's not that statement to statement, right? That's one thing to be aware of when you're thinking about transactions in SQL. So yeah, so either all of them are successful or none of them, right? And one other feature that SQL provides, that you can roll back a transaction, right? So if you let's say you inserted a row in a table, and you committed it and you want to roll back the transaction, that could be done too, right? In Elasticsearch, it's completely different, right? in Elasticsearch, the ACID properties are supported at document level, right? Not per transaction. That is one important thing, And the similar example, right? So there I said that if you have hundreds of rows that you're going to insert into an SQL table, and let's say here as well, you have hundreds of documents or even thousands, you're trying to index all those thousands of documents into an index, right? So document and index, you're trying to save all those documents inside an index. Each actual document is treated separately. So each document will have its own operation called index, right? So what happens? Let's say one of them got an issue. Elasticsearch doesn't it's not like all or none. It will only fail those things which has an issue, but the other operations gets through. So now this is one more example to stress on that it's actually per document level. We can roll back a transaction. So once you create a particular document, and let's say you want to, once you create a particular document, as I said earlier, every document will have a version. Let's say from version 1, you went to version 2. Now, for some reason, you thought, okay, let me go back to version 1. No, it's not possible, right? Version is just an arbitrary number that is there to show you how many number of times the document has been updated. But the only option for you to handle that is to delete the document and then create it again. So there is no rollback operation or functionality that is provided there. Let's next go to the complex things that are provided in relational database, that is like stored procedures and functions, right? So you're aware that those can be very powerful in SQL. Many projects or many applications many legacy applications, most of their logic is actually written in PLSQL, right? All those stored procs functions, most of the logic is written there. Most of the legacy applications have this issue, right? Now, when we come to this concept, Elasticsearch does not have any feature like functions or stored procedures as such. It's always like index to index and document to document specific. And partially can be you can achieve that. So in SQL, when I say stored procedure, right, or a function, it's very simple. Like the feasibility that it provides, right? It scales from very minute things like, okay, I have first name, last name, write a function which returns to me the concatenated name. I'm just saying, like, let's say you wrote a function like that. You have first name, last name, write a function which when you write an SQL function, when you send those two values, it will give you, a concatenated name, right? But then it's not the feasibility of SQL is not just limited to that simple things, right? It's much more complex. Inside an SQL, you can write inside a procedure, you can write much more complex algorithm, like trying to call multiple entities, getting the data, iterating through them, providing the results and then giving it back, right? Those kind of things cannot be done in Elasticsearch directly, at least not in perspective of stored procedures and functions, but still partial things can be achieved using script fields. So look at the example here that is present on the screen, right? Similar example. So we have a tweet index and there is a user ID, right? But for some reason, I thought there is a requirement that, okay, I wanted to concatenate in the end in the tweet called formatted output. That's the actual string, right? So if you look at this, the top section of this query on the left side is the same, which we already went through in the previous slides. But for the bottom section is where I was talking about script fields comes into picture. So I'm saying, okay, script fields is to create a new field called concatenated field. Okay, so created a new field called concatenated field, and then the language of that particular script is called painless. So if this is the first time you're hearing about Painless, Painless is like a scripting language which is provided by Elastic company itself. So I have not heard about Painless in other, if it's being used in other places, but at least in Elasticsearch is which is their offering basically, using which you can write this normal scripts, or any complex scripts that you want, which is not available on the uh, the actual commands that it is provided, right? So if you look at this, so what did it do? So script fields, concatenated fields, all the thing, and then you look at the output on the right side, right? If you look at the output on the right side, you see, like that's what I did. On the left side, there are multiple ways to do it though. Just like a simple example. I said, okay, source documents, tweet field, okay, whatever that value is, plus do formatted output. That's what we are seeing in the output on the right side, right? So there are much more powerful things that we can do with script fields, but still, it's not that we can, okay, if you, in SQL, if you have a stored procedure that you created with so much complex algorithm inside it, we can't actually do the same thing in Elasticsearch, but at least like things you can do with scripting, you can be basically doing with in Elasticsearch. Next, we talk about views. Okay, so in SQL, of course, like we use views for many reasons, right? So one of the major reason is like you have a direct exposure. You have a. I'm going to show in the screenshot as well. But let's say you have a table called customers, worldwide customers, right? So all the data or the countries that they belong to, like is just like all of the countries, right? But then for some reason, your business requirement has the requirement that, okay, I want to only access the particular section of that particular table where who belong to USA, right? So that's where views come into picture. You create a view, either that view could be for the entire table or it will be filtered, filtered view. That's what you can call it. So you'll create a view of a table, but you'll only create sections of it which you want or which is matching a condition, right? Yeah, other advantages of having views in SQL is, if you want to abstract out the actual database to the application, so you can create a view, and if you want to add a new columns to that table, you can do it in the backend because the view is not affected because it still uses the same columns as it was before. Later, you can update the view as well. In Elasticsearch, the similar version of Elasticsearch of views concept is called aliases. Okay, so but still, like alias is a much more powerful thing. We'll go in much more detail later. But in this perspective of, okay, let's say there is a whole chunk of data in a database, and if I'm creating a view in SQL, which is just taking partial output of it, and if I'm only handling that, if that is a requirement, you can do the similar thing in Elasticsearch with aliases and especially filtered aliases. Okay, so this is how you create a view in SQL, right? So simple example as I was telling earlier. You have a customers table, and then let's say the customers table is having 100 fields, 100 columns. You're not bothered about that. You just want customer name, contact name, and where their country is USA. Create a view, and that view is called USA customers, right? So this is like a simple example. If we switch to Elasticsearch, we can achieve the similar thing, right? Using called aliases. This is one way of creating an alias. You can also create another way when you're creating an index, but method doesn't matter. Like this is the concept basically. So similar approach, like in index called customers, you're creating an alias called USA customers, and the filter that it handles is like you're saying, okay, where filter term country is equal to USA. So out of all the data that particular index contains, if the country USA condition matches, that section of the data is what the USA customers alias would be handling. So this is like an example between the two, like how you can handle views. Okay, so before we go to the demo, shall we, do you have any more questions, or shall we move forward to the demo?
Hey Shri, I just had a quick question regarding the initial topic about using Elasticsearch as either a data store or a search engine. My question is it beneficial to use Elasticsearch for both the data store and the search engine, sort of like having the same having to use the same stack throughout? Does that make it easier, or is it preferred that you use Elasticsearch for one of those?
So it's not that, okay, if you use Elasticsearch as a data store, you can perform searches on it. No. You can basically do this. So see, for you to perform searches, right, and for you to leverage the functionalities of search, you have to have data inside your Elasticsearch, correct? If that data could be either your primary data store, okay, you store all of the data inside that, or you store only that data which you need for search perspective. It doesn't matter. But if you're asking that, is it okay if I use for both functionalities, it can be done too. It doesn't make any difference. Only thing is, like, when, and most company like few companies do that, like they don't have any relational database, they'll just have primary data store, which is Elasticsearch.
Mhm.
But the popularity, or the forums that I went through, and like when we did the research, like how most companies are using it, most of them responded that they're mainly using it for the search engine perspective only, and they have their traditional database system as it is, because they want to maintain their entities related. In Elasticsearch, you can maintain that, right? You have to denormalize everything. If you want your data to be normalized, then you have to have your relational database in the side.
Another important thing there, which is a little non-technical, is cost. It's costly to run Elasticsearch compared to running any other relational data store or any other kind of managed service there out. So a lot of other things come into picture as well. Yeah, no one is stopping you to use Elasticsearch with some indices just as pure storage and some indices as focus only on search. You can do that. Elasticsearch, as she said before, it will be able to scale properly if you have a few things configured correctly. But yeah, it will scale nicely horizontally. But then yeah, you will start looking into the cost and other sort of things as well.
That makes sense. Thanks.
I have one question. Couchbase, which is a similar NoSQL document-based DB, and how is it better over Elasticsearch? And it has the same similar functionality and full-fledged scaling features.
I think, to be honest, from my end, I recently got to know about Couchbase only when they went to NASDAQ, but I have very little knowledge about. Maybe Praveen.
Yeah, so what we are doing here is we are confusing with two different things here, right? One is a NoSQL data store, which of course Elastic is not the only candidate there. You have Mongo, you have many others available from the cloud services as well. If you think about AWS AWS DynamoDB or things like that, right? And Couchbase actually falls into the same category. Elasticsearch, being a NoSQL, yeah, that's there, but then it's more focused on the search, right? There are inbuilt analyzers available out there within Elasticsearch with a lot of cool aggregation capabilities as well on top of it. When you think from that perspective, you start thinking, yeah, Elasticsearch can do NoSQL stuff as well. You can store it as that data store as well, just like anyone else. But this is the specialized feature, which is the search.
Thank you.
Yeah, I think we are also not sure like how NoSQL here we're in comparison between SQL and Elasticsearch. We're also not sure about how NoSQL handles search capabilities, like the way Elasticsearch does. One of the major things that I read recently from Alibaba that they published is like many companies are using MongoDB as a NoSQL, but then they have this search requirement and MongoDB is not able to handle it properly. And they were saying that you can save a lot of your costs and a lot of your operation resources if you just migrate it to Elasticsearch and use it there instead of MongoDB. So maybe it has their ups and downs when you're using NoSQL for document search.
Yep. So think of Elasticsearch as a specialized NoSQL data store, right? Specialized for search. But of course, because of that, it's of course NoSQL as well. You can go and misuse it if you want. We have done that.
Okay, so I think we'll take other questions later if there are any. Let me go to. Let me know if you're looking at the screen. If you're able to.
Yep.
Okay, cool. So we have like in the session, and also probably I created for the purpose of this demonstration a small repo where for me to showcase or the differences between SQL and Elasticsearch pretty easily with a default data inside it. So I created tweet data and user data inside. This SQL pad is nothing but a UI that you can, a Dockerized container available that you can use to connect to a Postgres. So, and all I did now is just like clone this project and then just in Docker Compose up, which I think is running here. So all this has, just want to like go through. I'm not sure like how many of you are aware of Docker. It's just like it can be used to run much virtual machine containers, like and you don't have to worry about installing a large software in your machine. You can just like it's very useful for local development or also to containerize your applications. So yeah, so all it does is like I have a Postgres here, and then I have an SQL pad for this guy. So I'm connecting to Postgres, and we have Elasticsearch, we have Kibana, which I'm going to show to you just in a minute. And we have a separate custom Docker image that I've written, which does create the data in both SQL and Elasticsearch when the Docker is up, when this particular when Docker Compose is up. So that code of that is also here. I've just like written a simple Python application there with this mock data, and yeah, that creates the data here. That said, I don't think there is need of going through SQL pad, which I also not went through all of the things here, but it's just like for the purpose of this thing, instead of creating, when I went through like any SQL CLI or UI or GUI, I just found this and using this. But let me walk you through about Kibana. So this is for this repo. We will include there, and then so if you look at here, so this is how your Kibana looks like. Because I'm running it on a Docker locally, it doesn't like, it might be showing so many features here. It depends on what license you're working or what image you're running, right? And what license it has. But high level, it is like basically they are saying that different endpoints or different tools that they provide. And as I was saying earlier, here you can create analytics as well in Kibana. So just to recap, right? So Elasticsearch is our data store, right? And then Logstash and Beats and File Beats and other things are for data senders or data ingestion pipeline mechanisms. But then on top of it, we have Kibana, where we can actually visualize what your data, or it is powerful. It is powerful as that, and also it's as simple as just a GUI for your Elasticsearch indices. You can call both. So these are like different features that Elasticsearch provides, and security, observability, and stuff. And the one that we are looking at now is like dev tools. So ignore this error. I don't know what's going on. So what currently that we have here at console, this is where you run the commands, So one of the command, as mentioned in the slides, all of these are like REST APIs. Okay, so let's say if I do inspect and I do network, I'll just make a call. So there goes a REST API call, and I'll get a response actually, right? You see, I got a response, and of course, ES would actually show you there might be multiple calls going on here, but it will actually show you the actual output here, right? So there are different indices here that I created, or not all of them are created by me. And let me just walk you over simply here. The dot, anything that you're seeing with dot is actually the system level indices we can call, or like Elasticsearch maintains some cluster information or the index information inside those indices. So these indices, you don't actually do any operation on, okay? All these dots things. So if you see, this is what application program management. So application performance monitoring. So this is not for that. But then the indices that I created are these three. So it will just show like this. In the next session though, we would go with, I'll try to explain about, of course, we'll go in depth about what does yellow stand for, what does green stand for, and what does, what all these fields, individual, columns stand for, okay? So for now, just see, okay, this is how I get the list of indices in Kibana, okay? And, okay, so said that, so let's go with one by one. So the approach that I'm going to take here, I think we have around 45 minutes left. The approach I'm going to take here is like, I'll go one by one, each operation between SQL and Elasticsearch. But before I do that, let me show you CRUD operations. So let me do a CRUD operations in ES, right? ES short for Elasticsearch. So not sure you can see, but so to save time, actually, can you see the notepad?
No, not really.
Okay, good. Okay, because that has all the queries. I don't know. That's fine. Just like I wrote it before, so that to save time, but yeah, it's right here. So what I'm doing now, so this is ES session or Elasticsearch session. I'm just creating an index. This is creating an index. I could have went with much more like explaining you about settings, but I think it's too much for the initial session. We'll go on much deeper next session. But so this is an index, and I think I gave a brief overview about what those fields are, or how you create a schema mapping in the slides, right? So this is, I'm just creating an ES session where, name, total attendees, session type, created date, right? Seems simple. So when I create it, I get a response, good. So I get acknowledged, true, shards acknowledged. Of course, what is a shard? We'll go in next week, but let's just say, okay, everything is successful. So that's why you got true, and you got the index name too. Now, you created an index, pretty cool. Now you want to save a document inside it, right? There are multiple ways to save it. You can use post or put, but I'm just going with put now. So I'm just saying that, okay, ES session, what's the name? The name of our session, rough attendees 50, and the session type is meetup, created date. No, I just gave those fields, right? Simple create operation that we are doing. All good. So we got result is equal to created, and successful is equal to 1. Again, we'll go about shard information next week. Later, let me try to retrieve it, right? So if you see, all I'm doing, if you just look at, forget about the statements that I'm writing here. If you try to create a connection between this and REST APIs that we usually do in our applications, all these are just REST calls like HTTP GET, HTTP PUT, right? With a request body and a request, request param, like the one that I showed earlier, and then just the request URL, right? It's just doing that. So what we are doing here is like getting the object, which we did, and it gave you the object, right? Now, let's update the object, right? So let's say for some, after I want to update this 50 to 55, right? I can simply do that using this, right? Let me get it again, 55, all good, right? So we did create, read, and update. But then let's say I want to have one more field in this, and which is just like, for example, like mail attendees, right? And that's like I got a new field, and for some reason my application, right, it doesn't have this entire object. Like if you see the operation that I did just now, I gave 55, right? But along with this total attendees field, I actually gave other fields as well as part of this document that I'm updating, right? So now let's say in another scenario, I only get a new field and I don't have access to this existing fields, right? But I have access to the ID. So what we would do is there's something called doc as upsert that you can do here. So let's say, okay, out of this 55, made it in these are 25, and then doc as upsert is equal to true. You can use this update endpoint to do that. Cool. And then when you do a get, if you see the result as well, you'll see updated. And one thing, if you're observing, right, look at this version number, right? Of course, I can go back to serial, but the first time when I did it, it's 1. The second time when I did it, it's 2. And third time, because I did it, it's 3. Okay, just to show you visually how many number of times the document has been updated. Now, there is no way that I can go back to version 2. You know, the only way, and I don't even know, let's say if your document got updated 2 times quickly, someone said 55, someone said 60, right? This because I'm saying you that someone said 55, but the final value that you're looking at the screen will be 60, right? You don't know what was the previous versions that mail attendees total attendees value was. You know, that's tough to get. The only way is like if you want to index a new document, but you don't want to have that version, you just like create and delete. You can roll back to a different the earlier version. That's what I want to say. So when you do a get, you get this new field added to it, right? Without you mentioning all that thing, right? Now, one more thing is like, as I was saying earlier, no, I think at the time it is equal to true anyway, so that doesn't matter. But now let's go with, so we did create, read, and update. Let's go with delete operation. I can simply do this here. So delete is the HTTP method I'm using. Is the index name, and of course this is not the right one, and the type name, which is the type doc, and the actual ID, which is 1. As I was saying, as I was reiterating, previous versions of Elasticsearch always had a type. I mean, it allowed multiple types, but latest versions, I think at least from 6, it's always _doc. All right, so I can delete the document, and if I get it, you'll get no, right? So there's no document. And then if you want to delete the index, you can also delete the index as well. Cool. So we did all the 4 basic operations. Now, let's go back to because this is just like basic operations we went over that. Let's go to each individual table and then see, I mean, just to show you how the table looks like. Oops. Okay, this is just a table. So first name, last name, gender, and then, okay, this is June, but you know, just created in modified date. So just to see it visually side by side. So let's do one by one. Like, let me see, okay, give me the user where his ID is 1. It's just like basic query that you do, right? And you get, you know, this thing. And if you want to do the similar thing in Elasticsearch, what you would do is this. As I think I showed you earlier, the indices that is containing here, the information is user this index. This is the index name. And what we are doing is I want you to understand each individual operation that you're doing, again, with respect to REST endpoints perspective. That makes things easy to understand. All we are doing here is hitting the search endpoint, right? So it's a search endpoint, all good. Doing a GET request, and then I am sending a request body saying that what is my request body, right? The query match, and then the ID is equal to 1, right? Query is kind of like, you can think like a clause, right? If you're thinking of from SQL perspective, like different clauses, query clause, aggregation clause, sort clause, So query is just a clause, and you said match ID is equal to 1, right? And then you get the document, right? Is it the same document? Yep, it is. Now, if you look at the other thing, of course, is like, here they gave me all the columns, right? Now, let's say if I want to have the first and last name of this particular user. So how do I do that? Is I can go here, SQL simple, I'm just selecting those columns. I get Schofield, yeah. So in Elasticsearch, of course, there are multiple ways to do it. I'm just going to show you a simple one. It's like source, and I say what are the fields that I want, right? So the query stays the same because I actually want only for one user. And then I'm saying in the source bucket here, which is the actual JSON that we are storing, just give me first name and last name. That's what we say here, okay? And when you do a search, you get that, right? So you got the similar approach. This is just like this basic one. Let's go with joins now, right? So as we talked in the thing, so this is how, so we looked at this user, Schofield, and then, but I wanted to get the tweets that he did or she did for this, like, all those tweets basically. So how can I do? So what I did here, selected tweet ID, tweet, and then created date from tweet data, and then joined it with user data on the user ID, where in the user table, it's actually ID column, right? So when you do that, you get this, right? So you get ID and then the tweet and then the created date, right? In Elasticsearch, if you see, if you can recollect what I said in the session during the slides, there is no direct way for me to connect two indices, right? So here I have to do a query first, or have to do a query first to get the ID, store it ID in somewhere. It could be any programming language that you want. So ID is 1. Then go to the tweet index and then search, okay, give me the tweets where user ID is equal to 1, right? So it will give me that. See, it's just 1. So is it the same information? Yeah. Now, the reason, this is of course not optimal, as I was reiterating in the session. You don't want to do this. Like if you're trying to do this, you're still not utilizing all the functionalities that Elasticsearch provides. So one optimal solution is I created one more index just to show you. So if you're going to design Elasticsearch in your application or in your project, right, wherever, you have to design Elasticsearch with search perspective, right? You can't just copy, okay, however, what the mechanism that we are using to store in SQL, we'll just use the same. No. So this index is just an example to show you. Let's say my requirement is, as I was saying, your front-end application can be calling or performing searches via your user ID or name, right? That can happen. So what I would do is my index, like, of course, this index is not doing the job correctly. Of course, the design is wrong or not optimal. What I would do is create an index like this or design like this, where I would say I would store the username field in this tweet index itself, right? So when I do that, it doesn't matter if I search with user ID or with username, I'll get the information, right? Now, this, of course, you will know only if you know the business requirement of what are the different search things that we need to perform on our data. So that comes from that basics. So only then we can understand, okay, what are the fields that you need to add in the mapping, So this is just an example, basically. Now let's go to the next operation. Let's go to the aggregations. I think major aggregations actually, yeah, let's go with simple ones like arithmetics. Okay, sorry for this. Right, so I think earlier we saw user data table. So let's see again, what does it contain? Okay, so it contains the age, right? So I wanted to have, I wanted to know what is the min, max, and average ages of the particular user or all the users. So this is like basic arithmetic aggregations that we can do, right? Min, max, and average. So it just gives me this. All good. Elasticsearch also is very similar, almost similar, I would say, that you can do that. 1 second. Right. So what I'm doing, okay, if the same index user data is here and user is here, I'm doing a search. Now, when I said before, the before examples, all I showed was like with respect to query, right? Now, yeah, this is better. So let's say like two different indexes, right? So here I was saying that this is a query clause, and then you can say this is X clause or X section. So here we would have all the different things that you can do with X. Let me write it down one more time here. If let's see what all options do we have, right? So of course I'm not worried about query right now because I want aggregation on all the data, not a section of the data. So I'll just give X, and then I can give a name to it. I can do like, you know, average age, you know, something like that. And then you have ag type. So there are so many ag types that you can get as part of this API. You know, there are different APIs now, and there are much more advanced concepts like sibling aggregation, parent-child aggregation, and bucket aggregation, and all these things. We'll go in much deeper next session, but for now, let's go with like basic aggregations. Okay. So what I would do is, because I want average, I can just put average, and the autocomplete works fantastic sometimes or most of the times. So I can give that name as, you know, age, right? This is one aggregation though, right? But I want much more, right? So I can just go here. I can go min, right? I can say, oh, of course, I don't want it here, right? So I can cancel this, and I can go here. I can go minimum age, min, and then do the age again. Just copy pasting to save time. Right. So just observe carefully. This we don't need here. So when we do this, we get the results. But there's some difference here, right? Where are my aggregations, right? Oh, it's in the bottom, right? Is it the data same? Yeah, of course. But the thing is, even though you now in SQL, you didn't get any results, right? You just got your aggregation. You didn't get any results like any row information. Elasticsearch by default, even though you didn't ask for the rows, you didn't ask for the documents to be returned. And of course, this document has to do anything with this query, just like any document that is matching, because there is no condition that you gave any query clause. It's just giving you all the documents, right? Like some like 10 documents by default. You can undo it by just sending this, you know, parameter as size is equal to 0, which is the size of the number of documents that is giving to you. So if you do that, it just doesn't return you any hits, which is actually the documents that this query satisfied. And it just gives you, okay, what is the total documents that you have? 1,000, all good. And then the aggregations. So if you see, it returns these aggregations like this: minimum, maximum, and average, which matches with what we have here. Now, let's go to the next one. So the next aggregation that I planned is like, you have tweets, of course, and then you have users who are tweeting. Give me like top 10 tweets, right? Like give me top 10 users who tweeted most. I think it's with highest number of tweets, right? I can say. So this is like simple group by that we can do, right? In SQL. If you see the previous arithmetic aggregation, we just like simple example there, average and those. You don't have to use a group by there. But here you want to see like a ranking system kind of thing. You want to see, okay, what like give me the users who tweeted most, and order by descending, right? So all you're doing like grouping by user ID and limiting 10. So when you run it, so this is the results that you get, right? So this is a user ID and you get a count, and you get the count here. In SQL, let's do this here itself, right? So similar thing. I'm just going to do this for now. And because I'm going to do it with tweet user. So if we do here, what is this? Like top tweeters, whatever. And then there is this aggregation called terms, right? So this is very, I think very popularly used. So this basically gives you, okay, how many number of times did this term appear in the documents, right? It's giving you ranking on basis of that. So the field that you're going to select is what? So user ID field, right? Similar, basically. You're telling, okay, user ID, give a terms aggregation on user ID field and give me top 10, right? When you do that, and you get the results, right? Of course, the sorting mattered here, but it doesn't matter because all of them has 5, and then we have 4, right? So this is how you do ranking based on a term, aggregation. So how is it working internally? So it just is showing that user ID 376 appeared 5 times in the entire tweet table or tweet index, right? So user ID 376 appeared 5 times, or it appeared in 5 documents, right? So it is basically giving you descending order of the highest to lowest. So that is how we can do the term segregation in Elasticsearch. Moving on with that, we can go with, the next aggregation is a little more. And please don't think that, currently we are using Postgres and the syntax changes from SQL to SQL, right? Or the language to language, right? From SQL to MySQL, the Postgres to MySQL and MS SQL. So this is one of the ways that, let's say I want to know per month how many tweets do we have in the system, right? So before I do that, so let me just see what is tweet data, right? So here I have created date as someday, right? So here, but I have this ranging from 2020 December or before that to today, or like until recently, right? So, but I want to do an histogram, something called date histogram, and I wanted to do it on top of it with like on month to month basis, right? So this is one of the way that you can do in Postgres. I think other SQL languages differ on this. Haven't tried really on MS SQL and other things, but mostly they'll be the same, giving you the results. But when I run this, it will give you, because I ordered by the month. Okay, month by month basis, I'm actually getting the results, right? Okay, September 2020, I got 70, so on and so forth. In Elasticsearch, though, it's pretty easy and it's pretty simple. I don't have to do this date truncations and everything. As long as your field that you stored is by date, right? So here, so let's go back and then say like monthly stats, right? I can just do, date histogram, and the field would be created at, sorry, and we'll get an exception or a warning saying that this thing is deprecated, but that's okay. So when you do that, so if you see here, we got the same, right? So this is how You can do date histograms in Elasticsearch. And the warning is nothing but, so Elasticsearch does this cool thing that if they are trying to deprecate, they'll just give a warning that doesn't reject it right away. But in the future versions, of course, they say it's not. So what I would do is like do a calendar interval, month, to the same output, right? And you can do much more, like, let's say you want to do date, right? I got it, right? Now, I think this is the last of all of what I had between the comparisons. So let me go one step further. And so here I have created date. But these are when the tweets have been created, right? For some reason, you wanted to know, okay, these are okay, 2020 402 and 2021 598, right? If you wanted to know how many of them have been modified recently, right? So what you would do, so this is what I'm saying about like multiple aggregations on top of the current aggregations, you can perform that, right? So I can do X and then do modified month maybe, and then add type would be date histogram again. Create a date. Oh, sorry. Modify that month. Right. So in 2020, 407, 402, those were created. You can see here that those have been updated in 2021 July, right? So 156 of them have been updated. It's much more like I can go on right now. Let's see. I can do one more ags. Okay. Right, so I can go one more ags. And I can say top tweeters for some reason. I can go terms and like a similar example that we were using earlier. Okay. Give me, okay. So yeah, so out of 156, those were, or maybe I can give it 2, maybe, right? I can play around with it. And then here, out of 156 modifications that were done on the 402 tweets in July month, those were done by user ID 207 and then 256, like giving them a hierarchy there. So I think that's pretty much it from my end. These are like mostly different steps that we can do, or different concepts that we can handle between Elasticsearch and SQL. Let me go back to, so with the slides, we handle these operations. We created an table and index, and also CRUD operations, conditional logic. I think I can show you quickly that, and grouping by, and then text analysis as well. And then this is the GitHub repo. Let me go with this, right? So I think we have 5 minutes. So I have this, right? So I have this. I think I can show you this. This is some other index, right? So I have this. Now, let's say if I want to see, I really hope that the words match. This is lorem ipsum actually here. This is how different ways we can do the queries. And then I can say match and tweet. Awesome. So this is what I want. Now, if you look at this, really hope it is. Okay, if you look at this, and let me get this exact document, right? So when I got this exact document, this is the actual document that I received, right? So it was created by Sovin and user ID, blah, blah, blah. And then this is a tweet. Now, let's say it's New Year time, and then so many users are actually wishing Happy New Year, right, in Twitter. And you wanted to see, okay, give me all those users or the count of the users who gave a specific word, celebrations, right? Or in this case, let's say if this is the term that I'm looking for. And when I do this, it's not actually giving me just this, right? And I'm not actually looking for this exact word as well. This is the beauty of Elasticsearch, right? Now, let's say if I want to do the same thing in SQL, I have to do the percentile, the wildcard things, and then the word positions, the lowercase, uppercase, and other things. And one of the major disclaimer with the comparison of this text search ability is, although we acknowledge that SQL systems like MySQL, Postgres has this functionality, right? They also, I think from 2012, SQL relational database systems also started to embrace the text search, and they started releasing their version of text search. Basically, MySQL has it, Postgres has it, but it's so robust and so hard to implement. That's what I observed, and also upon the team discussion with the team, in the research that we did. That's why it's so uncommon actually. So it's very unheard of. Like very less people know that MySQL can also do some text search, because it only specifically does with stop word analysis and pure analysis. Whereas Elasticsearch, it's so easy to get started with. You can even get started with Elasticsearch tomorrow. You don't have to know much about how the text analysis is being done, and all the groundwork has already been done. So on that note, like here, I'm looking for all the documents where Viva must, I don't know what that means, but that the word exists, right? So all I did was match tweet Viva must. And if you observe closely, when I was typing this, I got tweet, which is actually the field, and I got tweet.keyword, right? Which was actually type keyword, as I was showing in the mapping section earlier. Now, okay, if I search with tweet.keyword, let's see what happens, right? Now, but before that, let me do with this, and let's see how many documents do we have. I think it was something like 66. Cool. So we got 66 documents, right? So this is a count API that you can use to give you the count of the indices. Either like if you do this, it will give you the total count, or if you have a query clause, it will give you the total count that is matching that query, right? So now when you do this, right? So when you do Vivamus, so you got 66, all good. Now let me show you the difference between tweet and tweet.keyword. When you do this, you get 0. Okay, and what is the difference there, right? So the difference is, so when I do, so here I saw Vivamus, right? In this entire text of so many random words, I saw Vivamus here. And not to go in depth, just to give you high level of what's the difference between type text versus type keyword. Elasticsearch performs analysis on text fields. Okay, so even though this particular field is having fields like these many words, Elasticsearch internally stores each individual word, right? And it's a Lucene concept called inverted index, where they make sure, okay, this word Vivamus appeared in this document. They'll store an internal, kind of like a map, okay? So when you search for the term like Vivamus, which is a term, that map, the key in that map internally that Elasticsearch stores, the key would be the words, okay? The key will be just the Vivamus, okay? Just the word. And then the value for that will be a list of document IDs where that word is present. This is simple. I think this is the probably one of simple example to say how search works internally. That's how it's very fast. So Elasticsearch knows when you search for Vivamus, okay, Vivamus is found in so and so documents, right? And it knows the document IDs. It will just give you the document. Simple. So that's how you do Vivamus. I mean, this is how the text analysis that is found. I think here, this point of how text analysis is done in stuff in SQL, easy to Elasticsearch. I think hopefully this would help to understand of how easy it is doing. Like you don't have to mention about any field exactly. Okay. The next thing is what? Like conditional logic. Yeah. So here, what we did is must. Similarly, we can also have must not, right? So for example, here, let's say match. I want memoirs, but I don't want this word. I'm sorry, because the words are a little tough to understand, but it's just random words that were generated. So if I do this, let's see the count. You got 66 count, right? Let's see count. You got 58. So handle the must not here. Okay, so this is the difference between must and must not, and how you can use, like if I want to do this, I can just go with this and count, and maybe it will give me entire thing. Like 887 of them didn't have this. So and then we have should as well. So must and must not are like, as the word say, English word must is like definitely should match, but should is something like either or, you know. So if you have should, you can just put match. And so let's say if I'm doing this, I remove must not. Yeah, so if I do must and if I do should, I can have again. So yeah, I think I can show this example. Give me 1 second. So I have one match here, and then have one more one, which is like piece and must, right? And then I say here, and one should match one. So either of that, so either of those two match conditions, I want at least one should match. So I'll get the result like, oh, so both of them should match, right? So I get 170, 171. So what I could have done is remove this and then keep it in another condition in must. So this gives me 8. So either this should definitely match, and then this should either match or not, that doesn't matter. So it will give me the number of results. So yep, I think that's pretty much it that we covered here. Oops. Now let's go back to the takeaways. So we understood the basics of Elasticsearch, hopefully, and then we had the CUDA operations, and we also saw the differences between Elasticsearch and SQL, and I really hope that you had those doubts cleared up, at least the concept-wise, like how to handle joins, how to handle primary keys and transactions, right? And how does Elasticsearch handle the key concept of SQL? So I think we can open we still have 10 minutes. We can see for the questions now.
Okay, so anyone has any questions? Anything remaining?
I have a question, but I'm not sure.
That's okay. Just go ahead.
Okay, so yeah, so basically the way I'm trying to think about Elasticsearch is that it's like a backend service that you add search queries to, and then it gives you a bunch of results. Now these search queries can be dynamic as well. Could this like, could we make sort of like a front end, like a UI version of Elasticsearch, where you have all these functionalities in the UI itself? Or is there already something like that where you just have a drop down maybe, and then you have the Boolean in there, and you have the keyword, you just type in the keyword, you add the Boolean must not or must have, and then it gives you the search results? I mean, it's not necessarily a question, but it's just something I was thinking about.
I think some of it, what you said, is actually already possible with Kibana, at least with dashboard perspective, where you have these drop downs actually. So if your plan is to do something with respect to like doing some operations on the conditions, or if or and or whatever, on top of data that you're trying to visualize. That can be done with Kibana actually. Kibana provides that. When you create a dashboard, you can say, okay, refresh when you want to just refresh it, right? It'll actually show you, if you update the condition, it'll actually show you the updated data that matches that condition. So it's there, but I think that's what I understood from the question actually. So
I think I will answer. So what Samir was asking was, do we have a query builder like user interface, right? Where he doesn't want to write the query. He wants some sort of drop downs and options available so that he can go and pick it up, and then the query is built behind the scene and then fired on Elastic, and you have the search results, right? Yeah. So definitely you will find something there. The whole idea behind what Kibana as query engine is, or query UI is, what she was using, it's much more powerful. And then the best thing I found in my experience there is that you have a lot of type ahead or IntelliSense there, right? So that you can just type and then it will give you a lot of things available, either the keywords, the options, the clauses, also the fields, if those are part of the mapping. So yeah, a lot of those things are available in Kibana's query UI or query editor as well. That's there. There's another question. Can you explain the difference between must and should again?
Yeah, sure. So must is nothing but and conditions basically, and should is nothing but or. I just realized the reason why the output didn't come how it's supposed to be. Just give me one. I'll make it quick. So here,
because you use one must and one should.
No, actually, are you seeing the screen? The Elasticsearch. So here earlier I gave one. Okay, I think that's why it was a little confusing. So when I give one, you say must here, which is end, right? So it's analogous to no, my bad. So it's analogous to, okay, in SQL you're giving multiple end statements, right? Okay, and. So that is, let's say, must. So this is where you'll want to put all your clauses that you want. So that could be and. So one more thing, like I can put range query here, which is created at, which is greater than now minus 5 days, right? This is an example. So my results that I wanted to retrieve need to follow, definitely should follow. It should definitely contain view-must, and it should have been created 5 days ago or 5 days and now, right? This is where you want to put end conditions. Now should is kind of like end, but you want, like, you're okay if it doesn't match or not. So what the reason why earlier you got less results? Let me remove this. If you remember, like, the reason why you got 8 is because it didn't care whether it would match this or not, because we put minimum should match as 1, right? If whether this is matching or this is matching, whatever the minimum is matching, it is giving. When I put 0 or when I remove this, I don't know what's the default value, forgot, but when I remove this, it just gives you all those things where both match, right? Does it make sense? Which let me see. Oh yeah, I think this would be it. Now in this particular condition here, we have 66 documents, and I've said must as this and should as this, right? Now let's see the difference if I remove this, because I put minimum as 0, right? I should get 66, right? Because I put minimum should match 0. Now let's say I remove this, right? And I put 1. The actual count is 113. Okay, my bad. I think I should do here to show you the exact thing I'm talking about. So let me remove the should here. So did you see? So the documents that are matching both view-must and Turpis are actually 8. So earlier when we actually gave like should here and we gave 1 during the session or when I was doing it, it didn't, like, out of all the documents it matched. Out of them, like, both of them match are only 8, right? That's why it only showed you 8, because it doesn't show you the entire documents, because the minimum document it match is 8. When you remove should, it will does an end condition for all, and then And for sure, you need to have all those documents that should be matching. So that's like high level difference there, but the difference is like end conditions or all the end clauses that you want, you will include them as must. And if you don't want like either or, then you'll include it as should. So I think, did that clear up or?
Yep. Another question. Do you usually use Elasticsearch as a source of truth, like a primary database, or do you keep your data in some other data store and use Elasticsearch as the mirror to index that data?
Kind of doing both.
Yeah.
Across different. Yeah, I think Praveen can answer this.
But yeah, that's the whole idea. I think we have a couple of projects where we are misusing Elasticsearch as the primary database heavily. But then we have a lot more other projects as well where we just use it as a pure search engine. That's pretty much it. While we have a separate relational database, which we are using as primary DB, or maybe some other sort of database, which we are using as a primary DB. So both of the flows that Shri has talked about, using it as a primary database or using as a search engine, you can do both, right? Using Elasticsearch. And you would definitely want to evaluate which way you want to go ahead with.
Yeah, and one more thing to add on that, when we researched like what are the different use cases people use, right? Some people are not even using it for data perspective. They're just using Elasticsearch for their APM. They use they're just their log aggregation. So all the log files that we print out your log files, right? And we get different errors like exceptions, all those things, and status codes. They want to aggregate that data. And so what they do, they use Logstash, ship all the data from their log locations wherever their containers or cloud services are, ship them to Elasticsearch, and then perform log analysis on top of it. And they can visualize on Kibana, and they'll know, okay, this request, all those metrics that they can build on top of it. So like Elasticsearch is much powerful. Elastic Stack is powerful, and Elasticsearch is basically the main heart where you want to store all the data to perform searches on.
We are ourselves using Elastic APM. The previously, I think you may have heard about ELK stack, ELK stack, right? Which has been renamed to Elastic Stack. ELK means Elastic Logstash and Kibana. That's what it is, right? For the log management as well as log aggregation and things like that. So APM is a suite of tools built on top of Elastic Stack with more information and more details, where it can now even compete with Splunk and Datadogs of the world, and then also work as a true APM, application performance monitoring tooling, with a lot of things, with the graphics coming from, or the visualization coming from Kibana, Elasticsearch behind the scene, providing the data store for all those logs or metrics coming from your applications or containers or anything. So yeah, we have been using in that fashion as well, just like an APM tool. So that's there. Another question is guessing hot, warm, and cold storage will be covered next week. I think, Shri, we probably need 2 more sessions on Elastic. We have some other things in mind to cover next week, especially about shards and indices and nodes, different type of nodes, and other sort of cluster management APIs and things like that. We'll see if we can squeeze everything to one session, or should we have 2 more sessions down the line. But I think we'll come back to that. Yep, the entire concept of hot, warm, and cold is pretty interesting with Elastic, and we have some good experience there as well, working with some of our customers.
The next session, as Praveen just mentioned, I think we will probably segregate that, as Praveen just mentioned, and try to give much more insights deeply about how things work in Elasticsearch, especially next session at least, like how scoring works, right? So I haven't talked about scoring yet. The reason, of course, one thing with Elasticsearch, even though if you go to documentation, of course, documentation is fantastic. We would definitely encourage you to go through Elasticsearch documentation. So diverse and well appreciated by entire, like so many people, so many developers. But it's so diverse that, like, let's say if I talk about scoring, I can't just say, okay, scoring is something, it scores, because it then like have to explain it further, right? So that deep level things is what we are planning in the upcoming sessions. So hopefully you'll actually get feel of, okay, how internally things work, what is shard, what is node, what is master node, what is data node, and all those things. So yeah, and yeah, that's pretty much it actually.
Cool. Any other questions? Okay, so probably that's the wrap for today. As we just mentioned, join us again next week for some deep understanding or advanced topics talking about Elasticsearch. So this series will continue. So see you next week. Until then, thank you. Thanks for joining, and then talk to you next time.